Good afternoon and welcome to today's webinar, Why Current Production Scheduling Tools Aren't Helping You Deliver on Time and How to Fix It, sponsored by Protective Flow Manufacturing. My name is Adrienne Selko, Senior Editor with Industry Week. Before we begin, let me explain how you can participate in today's presentation. First, if the slides or audio are not responding, press the F5 key to refresh in the webinar console. The toolbar at the bottom of your screen includes a help icon if you require further assistance. We welcome your questions during today's event. To submit your question, simply type into the Q&A window on the left side of your screen and then hit the Submit button. We'll be answering as many questions as possible during the Q&A session that will follow the main presentation. Today's session is being recorded and will be available on the Industry Week website within the next week for you to review. You will be notified by email when the archive is available. On your console, the Protective Flow Manufacturing logo is hot-linked. If you want to visit their website during the webinar, you can click on the logo and a new window will open. This will not take you out of the webinar. I would like to welcome our speaker. Mark Lilly is a partner of LillyWorks Protective Flow Manufacturing. Mark's passion is revealing the gap between the status quo within a company and the potential performance that could be achieved with a plan and the right software tool. He's been doing it for over 25 years from small to medium manufacturing companies, primarily by showing how software can dramatically improve their business performance. He especially likes to focus on the competitive capabilities such as delivery performance by helping companies with the seemingly continuous struggle with shop floor scheduling. After acquiring a foundation of knowledge in computer science and psychology at Cornell 30 years ago, he continued to learn both the technology and people side of the equation in making significant and lasting changes in the business performance of a company. Welcome, Mark. The floor is yours.
Thank you very much, and good afternoon, everyone. And welcome to Industry Week's webinar, Why Current Production Scheduling Tools Aren't Helping You to Deliver on Time and How to Fix It. My name is Mark Lilly. I'm co-owner of Synergy Resources, as well as a partner at LillyWorks. Together with my co-owner, we're with both companies. I'm one of three kids of Dick Lilly. Dick is founder of three fairly substantial ERP packages for manufacturing companies. ProfitKey is still being sold, Visual Manufacturing now Infor Visual ERP, and now LillyWorks as well. LillyWorks was a cloud-based, or is a cloud-based manufacturing software package started about 5 years ago. And by far its strongest functionality is the scheduling component, and I'm putting scheduling in quotes, and you'll understand why as we move on. But suffice it to say that we wanted to make that available to all manufacturing companies, whether they had an existing ERP or not. So they didn't have to replace their existing ERP to use this very strong scheduling alternative. We as a family, my brother and sister are also both involved very heavily in the business. They're both co-presidents of LillyWorks. We have a strong and rich family history of helping manufacturing companies improve their business performance, primarily around scheduling and material planning. George Clausel was one of the fathers of MRP back in the 60s and 70s. Joe Orlicki wrote his classic MRP book in 1975 and quoted George on the statement, all benefits implied as in a manufacturing company will be directly related to the speed of flow of information and materials. And I emphasize flow because that's really what we're going to be looking at and focusing on today, in a sense. What does managing the flow of information and materials need? Well, on the surface, it doesn't look like a tremendous amount. You've got, what materials do you need? When do you need them? What jobs or work orders do I need to create? When do I release them or send them to the shop floor? We can look at what's driving the priority of orders out in the plant. And then finally, how do I balance make to order versus make to stock orders out there? So on the surface, yeah, there's a lot. Not so much if you're looking at just one work order, but when you're looking at, tens or hundreds, or maybe even you're managing thousands of work orders out in your shop, then this becomes a complex problem. To complicate matters, we've got a friendly pit bull, well, not so friendly pit bull, living in each of our plants, right, in our shops, whether I'm a small shop or a large one. And this pit bull's name is variability. I won't read through the list. You can read these 8 bullet points, and I'm sure you'll quickly see issues that if you're in operations or anywhere near operations in a manufacturing company, you're likely spending some, maybe much of your day reacting to these different types of variability. So now the question becomes, how have we, and we meaning you all in manufacturing and we in software and technology, how together have we been trying to manage for you the flow of information, materials, and the variability of it all? Well, from a material planning standpoint, what you see is typically MRP. Right, that's been the default for about the past 50 years. From a production scheduling, planning, and execution standpoint, at least from a systems standpoint, it's finite scheduling or an advanced planning and scheduling software application. So let's take a look first, since our topic today is on-time delivery. But let's take a look first at production scheduling. Most manufacturing companies struggle with shop floor scheduling. They're using whiteboards, they're using spreadsheets, or they're trying to use complex, sophisticated, advanced planning and scheduling tools that are either embedded in their ERP or that are outside as bolt-ons. What we found, and my partner and I, as we manage in our company, we manage over 500 ERP customers. And the ERPs we manage have some excellent scheduling functionality embedded in them. It's really very good. And that functionality has grown over time throughout the years. Unfortunately, what we see is that there's a very low adoption rate of scheduling tools in the marketplace. Why is that? Well, let's take a look at backward scheduling, for example, traditional finite scheduling. And what we've just seen happen here is a small set of work orders or jobs are first sorted by due date, right? And then each of the jobs, each of the work orders, and all their operations are brought into and onto the schedule to allocate current and future capacity. Then the next work order comes in by due date and allocates all of the capacity needed for all of its operations, and so forth and so on. So what you get here is more of a focus on loading capacity than it truly is about trying to figure out really, or what the best answer is for what job should I be working on right now, either shop-wide or in any particular resource or department in my shop. By definition, it's a program, so any priority that it does produce is as good as the last time I ran the program. As I mentioned, it places all of the operations of a work order or job at once. The reason I point that out is if you're executing out on the shop floor, you're not really, if you're in a particular department right now, you're not so much concerned what the priority of the next or future operations are going to be. All you're concerned about right now is this operation in this work order compared to the other operations and other work orders and how they're prioritized against each other. In other words, which job should I be working on right now in this department? And this isn't really answering that. By definition, you've got to have really pretty accurate setup and run times. I mean, these rectangles that are taking up and allocating the capacity are are determined by setup and runtime. So they better be pretty accurate if you want to create a schedule that's even semi-believable. And then finally, and unfortunately, the finite scheduling, especially backward scheduling, has really no room for variability. So in a backward schedule, you're essentially telling the system, plan on finishing the last operation in this work order on the day I need to ship it. Okay, so knowing we all have our friendly pit bull hanging out in our shop wanting to tear us down, is that really an equation for successful delivery to our customers? The other thing we want to look at, and I've touched on it already, is the prioritization. So what we do is we run these scheduling programs, right? And it using a variety of algorithms, it comes up with the load on our capacity, and then we assume that this plan that's been created is the right way and the best way to execute out on the shop floor. So we print this out. It's called a dispatch list. We print out the order of operations from the resulting scheduling run for each of the departments or resources it needs to go through. And then we walk that out to the shop floor. And the folks out there kind of look at us like, okay, you want me to work on what, when? How did you come up with the order of these jobs? So it's hard to explain, and it's a bit of a black box. And there's often a disconnect between the folks who are actually executing out on the shop floor and the folks who are doing the planning using these tools. How can we change this up? What can we do different? Well, instead of creating a plan and trying to execute against that plan, how about we focus first on what the right priority should be on all the work orders and jobs? What is the real-time, how can we determine the real-time priority of any job across the entire shop or in any department or resource, okay? Without having to create a plan, without the, dead on and really accurate setup and run times, and without having to have the overhead of maintaining a complex scheduling or advanced planning system. So that's really the question. How could we go about doing that? Protected flow manufacturing is an execution methodology that we believe has the solution. It combines three concepts from manufacturing improvement philosophies. Let's cover them now. The first one is time buffers. Okay. We talk about introducing the idea of time buffers. A car analogy is a good one. If you commute to work and say your commute on a Sunday morning at 2 in the morning would be, say, 20 minutes, right? There's no traffic, really nothing in your way. But on Monday morning when everybody else is on the road, construction's going on, what have you, you better leave. If you want to get to work at 8 o'clock, you better leave probably around 7:15, maybe earlier, to make that 20-minute ride, right? So you give yourself a buffer. You need that buffer if you want to get to work on time. Well, it's the same sort of thing in production, right? So the idea here is, what are you using a buffer in production? And if so, how big is it? How big of a buffer are you using? Here are a couple questions to determine that, and these are very powerful. So if you don't know the answers to these, definitely write them down and ask somebody in operations who can help you with this. But essentially, the first one is actually more for the sales folks, and that is, what's the average lead time that sales is quoting to a customer or prospect? Right? So in a typical custom manufacturing environment, it might be 6 to 8 week job, right? 6 to 8 weeks. Then the follow-up question to that is, well, what's the actual touch time? If nothing else were in the facility, you had the material, all the machines and people were at the ready to manufacture that part or product, how long would it actually take you to do it? And the answer we hear is often and usually a fraction, sometimes a very small fraction of the lead time being quoted. So on that 6 to 8 week job, we often hear, a couple weeks because it has to go outside once or twice for heat treating or plating, or sometimes even, 5 days. Sometimes we even hear 3 days or less. So the idea is, right, you're quoting 6 to 8 weeks, but you only have 3 days of work that needs to be done. So in spite of having that huge buffer, right, why are we struggling with being on time? Okay, so that's one of the answers we hope to questions we hope to answer here as well. But we're using buffers, right? And we know we want that buffer. We know we need that buffer. And if we had a job that took 3 days of work that needed to be done, we would never. It would be crazy to release it, 3 days before its due date. We just know that there's contention, things happen between operations, things happen during operations, Murphy hits, there are bulldog attacks, et cetera, et cetera. The second concept we use in protected flow is the idea of how much, looking at how much work we're actually releasing and sending out to WIP. We often go into manufacturing facilities, and there's this idea, it's seemingly intuitive, that, gee, the sooner we release material out to the shop floor, the sooner it's going to come out the other side as finished product, right? Well, not so fast. There was this fellow named John Little who studied mathematical Q theory at MIT, and he proved this pretty simple-looking theory, which became a law under his name. And it simply says that the number of things or people or items that you put into a quote-unquote system is directly related to the T, or the length of time, that any one of those things or people or items is going to be in the system. So a system could be a bank, Q theory, right? A bank, a grocery store, an amusement park, a manufacturing shop floor. So, you go to Walt Disney World on spring break and you have a list of 5 rides you want to get on. You're going to be at Disney World a whole lot longer than if you go in, say, the second week of September when everybody's back in school, right? The neat part about this is that it's directly applicable to a shop floor. The more work you release out into WIP, the longer period of time any one of those jobs or work orders is going to be in WIP. But the fun part is the inverse of this law is also true. The less we send out into WIP, the faster that any one of those jobs or work orders is going to flow through all its necessary operations to completion. So more slows things down, clogs things up, confuses true priorities, sending less out into WIP. To a point, of course, we don't want to starve our resources, but sending less makes whatever is in WIP flow faster. The third concept is about prioritization. So how do we prioritize work once it's released? So that's the question we're going to examine here. Oftentimes we walk through facilities and you kind of wonder if there's really any priority system at all. It's a little willy-nilly. On shops that are relatively disciplined, you often see prioritization on due date, which is certainly better than nothing. But you have to be careful with due date, because you can have, especially in a high mix environment, you can have jobs that are due, say, the first week in December, that have quite a few operations, maybe need to go to outside resources once or twice, that would be more in danger of being late if I didn't get started on them right now than a job that's due, say, the first week in September. So prioritizing work strictly by due date can actually make jobs later that are otherwise and in reality more at risk of being late right now. So that's the fallacy with due date that we need to be careful of. Many shops have expediters, especially at the end of the month. The interesting concept to look at with an expediter is simply how they prioritize work. When something really needs to get out, how does that happen, right? And it's either the salesperson or the customer that's screaming the loudest, right? Oftentimes it's financial reasons from the top, is, I want to get a high throughput dollar number out at the end of the month. But generally speaking, an expediter is going to find that job or work order that's most in danger of being late, and that's the one they're going to push through. Protected flow manufacturing combines those three ideas, those three concepts, to focus first on priority without having to run any scheduling programs. Here's what it looks like. I've got 4 operations here, and operations 10, 20, 30, 40. The length of the rectangles is determined by an estimated setup and runtime. So this is kind of the cumulative work that I need to get done to get this job complete. It's 4 operations, spans about 2 days of work. Now, this right-hand edge is my due date. Here's my target completion date. That's when I need to get all 4 of those operations done. As I mentioned, I'd be crazy to release this job right here on Monday afternoon, so I want a buffer. I need a buffer to make sure that I have sufficient time for contention with other jobs, Murphy or my bulldog that's going to hit, so that I can feel confident that I have enough time to get all these operations through the final operation complete by this date. So this buffer is protecting my due date. Now on the left-hand edge, this is my release date. Now what this is doing is saying, please don't release material any sooner than this date. If you do, then you're violating Murphy's Law. You're sending too much out into WIP. You're confusing the true priorities. You're clogging up resources and slowing things down. So this left-hand edge is protecting us from sending too much out into WIP. Now, once a job is released, then as time goes by, the buffer gets automatically eaten up. And the priority of the job at any point in time becomes the amount of buffer from a percentage standpoint remaining. The less buffer remaining, the higher the priority. And it doesn't matter what the length of this, we call this a framework, showing the overall lead time of the job. The framework length could be 3 months, or it could be 3 weeks or 3 days. It doesn't matter. Whatever percentage buffer remaining I have, that's going to drive my priority. The less percentage buffer remaining, the higher the priority. Now, we do also bring in the idea of how much work is remaining. Okay, it's a subtle refinement. And we create a ratio out of this called the threat level. So the beginning of every job, you have 100% work remaining and 100% buffer remaining for a threat level of 1. So the idea is if I'm doing work faster than buffer is getting eaten, then the threat level will drop below 1. On the other hand, if buffer is getting eaten faster than the work's getting done, then that threat level is going to go higher than 1. Okay? Let's take a look at a couple examples. So here I've completed operation 10. I have 85% of the work remaining. 25% of the buffer has been eaten up, so I have 75% buffer remaining for a threat level of 1.1. I feel pretty confident here that I'm going to get this job done on time. Now I've finished operation 20. I have only 60% work remaining. I've got 65% buffer remaining. I feel even more confident now that I'm going to get this job done on time. My threat level is even below 1 at 0.9. Oops, a couple days have gone by, haven't done anything on this job. I still have 60% work remaining, but just 30% buffer remaining. My threat level has popped up to 2. To emphasize the point, if I hadn't done any of the work yet here, I had 100% work remaining, my threat level would be at 3.3, even higher. This methodology is this simple, and it's dynamic. At any point in time, you can look into the system and see shop-wide or specific to any resource or department, what's the most important job I need to be working on right now. If I print the priorities out, they look like something like this. Here's my department, Resource BBB. I've got a few jobs coming through here. Job 10,004 has 37% buffer left, 81% of the work remaining for a threat level of 2.1. Job 2 has more of its buffer remaining at 51%, less of its work left to be done for a lower threat level of 1.4. So even though Job 2 is due 4 days earlier than Job 4, I need to be working on Job 4 first because it's more in danger of being late. It has a higher threat level. If we were to look into the software, this is a monitor view or that you can put up on a big screen TV out in the shop. You could use tablets. You could use your iPhone. This is all web-based, so you can display this however you like. You can print it out, or you could send the data to your own MES system if you already have one, that type of thing. But in any event, this is what an operator might see. Here I am at a certain department, or this could be a group of departments. These are all the jobs coming through, and very simple priority. You color code these based upon how you'd like to see them in terms of what range should be red, which one's yellow, which one's green. This top job has the highest threat level. It's the one that's most in danger of being late coming through this department right now. This is the one I want to be working on right now. It's that simple. Threat levels change, of course, dynamically and automatically when customer due dates change. Here's a work order that has 3 days of work to be done, and it's got 12 days of buffer. So at the beginning, it's got 100% work, 100% buffer remaining for a threat level of 1. Now I'm 8 days after the release, so I've eaten up 7 of the days of buffer. I have 5 left. I've done 1 of the days of work. I have 2 left, so I have 66% work remaining, 41% buffer remaining for a threat level of 1.6. Now my customer calls and wants this job 3 days earlier. Well, what happens? You put the new date in the system. You don't have to run any program. Very simply, customer wants it 3 days earlier. Enter the date. Don't have to run a program. The framework simply shifts 3 days to the left. Now I have the same amount of work left to be done. I've only got 2 days of buffer left. So my buffer drops to 16%, and the threat level pops up from a 1.6 to almost a 4. So this job will likely pop right to the top of the queue in any department that it still needs to go through to get done, kind of expediting itself, if you were. Similarly, if a customer calls and wants to push a job out, so now originally I have 5 days of buffer left. Now I have 8 days after I change the date. Framework automatically shifts over, giving me now 8 days of buffer, or 66% buffer remaining. My threat level drops from a 1.6 down to a 1. This job will de-expedite itself on that priority list that the production folks see. So here again, here's my priority list in the software. See this bottom job down here, job 10,005? It's got a threat level just slightly over 1. Really very comfortable. I'm pretty confident I'm going to get that done on time, not a problem. Customer calls, pulls in the want date. Now that job pops right to the top of the queue, and its threat level is now 6 something. This now is the most important job I need to be working on in this department. Didn't have to run a program. Didn't have to do a batch scheduling run. Another view you get with the when you have everything in the software is this actuals where my WIP is. So in other words, this will show on a job by job. Each of these dots is a job, or if you have hundreds or thousands of jobs out there, these may be clusters of jobs in a certain area. But the idea here is, and ideally you'd want your jobs kind of walking down this diagonal line where percent work remaining or the work is getting done as the buffer is getting eaten, okay? So that you get in earlier on time. This job up here on the top right is certainly the outlier. It's got 95% of the work remaining and only 20% of the buffer remaining. So it's not late yet. If I'm diligent, I could get all the work, get working hard and pull it into the green zone to be on time or even early. But if I don't, then it will surely drop out the red zone and become a late job. Here's what it actually looks like in the software. And this is a before picture of one of our customers where we have, you can see quite a few late jobs over here. You may not be able to see it on the slide, but there in each of the dots, there's a number, and the number designates how many jobs are in that rough area of having a similar threat level. Then we have quite a few early jobs over here, jobs that probably shouldn't have been released yet, but even work has been reported on them, which may be a reason that we have late jobs over here that haven't been worked on, right? And then a warning up on the top as well. Now, after PFM, after you've been using PFM for several weeks, couple months, then you tend to see your jobs migrate towards this diagonal line. So you stop doing the early releases. You want to stop that, and then so jobs get worked on as their priority dictates throughout their life, and then the late jobs tend to migrate more towards on time as well. So how do you fix scheduling? What we're saying is don't schedule at all. Instead, execute according to protected flow manufacturing priorities. It gives you a hyper focus on making sure that everybody in your company are all committed on making sure that jobs are getting done when they need the attention. No sooner, which is wasteful. If you've studied lean or done any lean, certainly you know doing things too early can be wasteful, and certainly not later. Make sure you're not sending too much into WIP. We talked about that and know that that's not a good thing. And it speeds flow. Benefits to you as a company are better on-time delivery to your customers, reduced WIP, which by definition per little saw increases flow, also has great advantages for financial performance, just from even a cash flow standpoint, having less WIP. But also better financial performance from having higher throughput and faster flow through the shop. We have over 50 manufacturing companies using this right now. We have a number of testimonial videos and blog posts out on protectedflowmanufacturing.com. I urge you to go out and take a look. I'm going to highlight 3 of them right here. The first is Arch Global Precision. Arch Global has several different divisions. They started using this in one division. Overall, they struggled mightily with getting scheduling going in their ERP software. And they adopted protected flow manufacturing quite well out on the shop floor. And the reason I say that and stress that is this is really where the rubber meets the road. If the folks on the shop floor aren't actually executing based on these priorities, then you really won't see any benefits at all. You really need adoption out on the shop floor, and Arch did this quite well. And in the video, the testimonial video, describe kind of how it was done. An example of one operator who saw one job come through and really questioned the priority and said, why are we running this now? Now, probably looked at the due date and saw that it was a much later due date. Said, we don't run these, this early. Well, he pulled back the curtain, so to speak, and dug into it and saw that the framework in protected flow showed that indeed it was more in danger of being late than any of the other jobs in the queue right at the moment. So he understood, and in fact, what he realized is that job needed to go outside twice. He had never really understood or seen the extent of the downstream operations after his operation that he was working on. Once he understood that, he realized that what the priority was, and the light went on. Arch also has make-to-order jobs and make-to-stock type jobs, and there were literally internal some internal conflicts about that, about truly prioritizing make-to-order jobs versus make-to-stock jobs, and which ones should get the priority. PFM has a very unique way of being able to prioritize both make-to-order jobs, which are prioritized based on due date, and make-to-stock jobs as well that are based on a due date, but a due date that's driven from the replenishment level of a planning buffer. Let me put it that way. So it's a very intelligent and dynamic date on a make-to-stock job. And that date will then, of course, drive the framework, which will then drive the priority right along with a make-to-order job. So both make-to-order and make-to-stock jobs have their own threat levels, which relative to one another are a true picture of what the relative priority should be. And if we have time at the end, we'll get into that as well a little more. SATURN struggled with ERP scheduling as well. It was a different ERP system than Arch. They had poor on-time delivery, was in the 60s percentile, and they knew they needed to do something different. They implemented protected flow manufacturing, and over the course of really 3 short months, their on-time delivery improved up to over 90%. Now, as they continue to make improvements, it's approaching 96%. So really phenomenal improvements by having this focus on always knowing and always working on the right job at the right time across the entire shop, you're able to improve fairly quickly and pretty dramatically. Graphicast was originally an ERP finite scheduling user. Just found that it was finite scheduling was nervous and jittery, especially with the changes. Every time you're in the schedule, it would be a completely different picture, which led to some frustration. They used a DBR drum buffer rope scheduler for years, which worked well for them, but it was missing some components, namely the priority mechanism of it was simply buffer penetration rather than both the work remaining, and so you could see how much buffer you had left, but you couldn't tell how much work remaining you had. The other detriment was that there was no future-looking planning function, which I haven't yet touched on, but for emphasis reasons. But that was a reason they went to PFM as well. Customer service folks, when we showed them protected flow manufacturing, literally screamed with delight on the conference call when they saw that they would now be able to tell a customer with a pretty good degree of confidence when they'd be able to get their order. We'd love you to try this. Okay? We'd love you to stop being frustrated with scheduling and start executing in the right way with protected flow manufacturing priorities. We have the ability to offer a very low-risk, low-cost 90-day trial. We'll come in and set up the software. It's cloud-based software, so it's really just about giving you a login to it, setting up a database. It's up in the cloud. You don't have to set up any hardware. We don't have to use your hardware. We'll teach your internal staff about PFM, again, the key here is that the folks on the shop floor and management is behind it, that we're going to use and going to prioritize work based upon PFM priorities. So it's a quick, focused change management approach within, really 2 to 3, maybe 4 weeks at the most. We want everything set up, folks trained, and understanding what they need to do, and then by the beginning of week 5, start prioritizing this way. So we have a full 2 months for you all to see the benefits of how things can improve, how flow can speed up using this approach. So once you're going, you're simply executing jobs and work orders using these priorities. So you're releasing work only at the start of a framework, and once it is released, you're prioritizing it based upon the threat level at the time of that work order or job. We are very confident that if you try this, this is going to revolutionize the way you're able to deliver to your customers on time, in less time, every time. As I mentioned, it's cloud-based. It's up on Amazon. It's very secure. If you need deeper security, GovCloud is also available. It's software as a service. So again, whether you do the trial with us or you move forward after the fact, it's a very low upfront investment. It connects to any ERP software. You can either pull information out of your ERP and import it into Protected Flow, or we can set up an automated connector for you that will automatically do the pull from your ERP and send it up to PFM in one fell swoop. The interface is simple, and it's one way by default to keep it simple, from your ERP up to PFM. If you want to bring information and push it back down to your ERP, we can help you facilitate that with APIs. The return on investment here is fast. The value proposition and what you need to ask yourself is really, what are improved delivery times to our customers worth? Can we use shorter lead times? If we were able to quote 4 to 5 weeks instead of 6 to 8 weeks, would that be a competitive advantage? Would we be able to gain more business or to keep our existing customers? There is a planning component to Protected Flow, and I've left it to the last because it's meaningless if you're not executing with Protected Flow manufacturing priorities out on the shop floor. When you look at it, it's easy to confuse it with quote-unquote scheduling. It's not scheduling. Priorities are real-time from threat levels of frameworks. They're not from the last scheduling run. Okay. Now, planning is a program, and it's called the Predictor. And all it does is it simulates this execution methodology walking out into the future. It exposes obstacles that will get in the way of on-time execution out in the future, whether that's machine bottlenecks, people constraints, or material or tooling availability. It highlights jobs that will be late or that will have a high risk of being late in the future. And again, I can't stress this enough. It looks like scheduling, but it's not. This is the results in the software of running the Predictor program. So this is showing me where each operation on each job or work order will be placed out in the future according to what their threat level priorities will be out in the future. Okay. To do a very quick simulation example, I've got 5 jobs here, 10,000, 1, 2, 3, 4, and 5. They all have 4 operations. They all have their respective buffer size. They all start in A, finish in D. Some go to C, then B. Others go to B and then C. So the way these are released are, here's the due dates over here on the right-hand side. The release dates are from backing off the buffer, backing off the work. So on the left-hand side of each framework is the suggested release date. So we queue them up based upon the release date and then send them out into their first operation that way. So I've sent a few out already. Here I've just placed the first operation in work order 5. Once it finishes up, so today is June 1st in 2017, but I'm simulating in this program, in the simulation view, where today is June 7th. So this is showing me that I've placed operation 10 of job 5 here. Once that finishes, then I'm going to want to bring that down into resource B. But job 4 will be running there already, so it's going to have to go into wait mode. In fact, there are 2 other jobs waiting for job 4 to finish as well, job 1 and job 2, over here on the right-hand side. Once job 4 finishes up, how does it prioritize these 3 jobs? Which one will be placed there? Well, to determine which one will have the highest threat level priority at that future moment in time, we take a look and step back and see where their respective frameworks will be. So job 1 will have 87% of its work left to be done, 75% of its buffer remaining for a threat level of 1.1. Job 2 will have 51% of its work left to be done, almost 80% of its buffer remaining for a lower threat level of 0.6. Job 5 will have 86% of its work left to be done and a full 93% of its buffer remaining for a threat level of 0.9. So which of these jobs will be most in danger of being late at this future moment in time? Well, the one with the highest threat level. That's job 1. So job 1 will be placed in that resource at this future moment in time. The other 2 will continue to wait and deferrals will be logged. So we continue to move along like that, resolving each of the conflicts along the way in that same manner. Okay, so I'm walking through a simulation. The program takes a few minutes to run. I'm walking through it, just showing you the logic behind it. So the idea here is that I can see how all my jobs will be and in what order they will be worked on out in the future, given their protected flow priorities. So I can clearly see that resource B is going to be my bottleneck. What's interesting is if we step back to the original frameworks, we can look at where the predicted finish date lands on each of the frameworks. And these all look pretty good. I have a fairly comfortable amount of buffer remaining in each of these work orders left over. So I feel pretty good about getting all of these jobs out on time through that simulation. Now, if we compare this against a finite forward type of program, a little bit comparing apples and oranges, but it's an interesting exercise. So the same jobs, same frameworks, I'm going to release them in the same way. The forward finite scheduling is basically going to ignore the buffer, but it will take each of the work orders. It will prioritize them based on due date, well, in this case, release date, actually, since we're doing forward, and then place all the operations. So all the operations of job 2 are first placed, and then job 4, and then 1, and then 3, and then finally job 5. So on the surface, it looks pretty similar. I get the same bottleneck, but when you dig into it and look at where the predicted finish dates are of each of the jobs, these all look good. This one has all its buffer left. It was the first one placed. That was job 2. Job 5, though, if you look at that one, is actually predicted to be late under finite scheduling. Why? Well, because at the point in time back here, when it was deciding which job to go in, it didn't know that job 5 was the most in danger of being late, so it placed another job with an earlier due date instead. So job 5 was essentially starved out of the bottleneck, and it's going to be planned to be late. Again, and to emphasize the point, protected flow manufacturing does have a planning component, but it assumes, and it's very important, that you're using the threat level priorities out on the shop floor in order to have it be meaningful for you. But once you are, it's quite meaningful because it's doing a simulation of what you're and how you are actually executing out on the shop floor. and that's based upon the threat level priorities. I'm going to stop there. I think we're 3 o'clock now, so if I know we got a late start, but I'm going to open it up now for questions.
Okay, great. Thank you. I just want to remind our audience to please take a moment and fill out the feedback form on the left side of your screen while we do the questions. The first question is, can you add weight to the flow priorities, such as profit and the importance of value of one customer over another?
Yes, great question. And actually, yes, there are override mechanisms for threat level. So you can, at the customer level, you can prioritize customers, and then all of a certain customer would have a higher priority than anyone else overriding threat level priority. There's also a way, if you see on the slide I'm showing now, it might be hard to see right on the upper right of that oval is a little button that says dispatching. I could click on that and actually drag and drop any of these. So if I wanted to drag one of the operations up above another, I can manually override it as well. But yes, there are override priority mechanisms to threat level if you wish to do that.
Okay, next question. Have you had success implementing PFM in an EOT high-mix, low-volume environment?
Yes, most definitely. And in fact, one of the sections, I stopped short. One of the sections I was going to get into is material planning. And Protected Flow Manufacturing has an option to work with a material planning and inventory management philosophy called demand-driven MRP. And there's some very, very unique and very interesting features and functionality provided there that make the management of end items, stock subassemblies, and raw material and components very simple and much easier to manage and much more effective to manage, I should say, as well than traditional MRP. And unfortunately, I ran out of time to be able to show those. But the short answer is yes, we do. I spoke PFM, on the surface does appeal more so to a high mix to custom manufacturer shops, but by all means, it does very much apply to standard product, make to stock type facilities, as well as you mentioned, high volume, low mix type environments.
Okay, the next question: does this protected flow model work in a contract manufacturing environment where some of the input materials are procured by the CM and others by the customers?
Oh, absolutely. Yeah. In fact, it's really up to you whether you even want to look at materials at all, right? By default, and really what I showed here was just protected flow manufacturing regarding the routing, the internal routing that you as a contract manufacturer would execute, right? Not even, and I didn't even really acknowledge or look at the material side of it at all here. But as I mentioned, there is, if you wish to do that as well, you can also bring the material side of it in and manage materials, again, whether they're raw materials, components, subassemblies that are make to order or stock subassemblies. Those can be managed through PFM as well, with the same priority mechanism. And as I mentioned with the video testimonial of Arch Global, that was one of their challenges as well, right? How do we balance? How do we prioritize the make to orders that we need to get out by a due date versus our make to stock, which we just need to make sure we have decent replenishment levels on. That's a great question.
Next question: how about a factory with 1, 2, or 3 color wheels, and those wheels that have opposite or other sequences?
I'm not sure I fully understand the question. I think it might be, you might be talking about wanting to sequence jobs based upon certain colors, which is a common in manufacturing environments, especially where you want to do either like colors in paint or even like diameters in a machine shop. I don't want to do a whole nother setup for a larger diameter if I've got another job, two behind that I can sneak in and save a setup type of thing. And protected flow does allow for that. So you actually create setup codes, and in that production execution window that showed the priority list, it will simply look for on the job that's running or the next job that is to be run. It will look down the list for similar setup codes and bring those up to the top with it. Kind of again overriding its threat level. That's up to you.
Okay. Next question: how do you apply this concept to a refinery?
I'm not sure if the refinery has multiple operations. Really, the question we ask right at the outset is, how many operations do you have in a job or work order? If you're one and done, if you're a stamper, for example, and you get material and it goes through a stamping machine and that part is done, then this is not for you. You can schedule off a spreadsheet for that. If, however, you're managing 2, 3, 4, or more operations in sequence through different departments, then you do have the challenge today, right, of those departments knowing which job as they come through should be worked on next. Which job is most important to be worked on right now, and that's the problem we're solving. And many companies will tell us it's not the first or second operations where you're helping us out. We know what we need to be running on the first or second, primary machine operation, for example. It's the downstream operations, it's the secondary operations, or it's the outside services where we're dying. We come up with, we've got an 8-week job and we get to week 7 and we realize this thing hasn't gone out yet, right? So that's where this really helps. You're able to see what the true priority is. In the example I just cited, in week 3 or week 4, that this thing needs to go out, and it's going to go out, rather than it sitting around and getting late.
Okay, next question. Can your system cluster like jobs improving efficiency, and thus reducing material changes, machine setups, packaging, etc.?
Yeah, I think I just answered that with the other question about the color wheel, which I kind of assumed was that type of question. So yeah, with the setup codes, yes, you sure can. And what's fun is it solves it both in the execution standpoint. In other words, when I'm looking at the production execution window, I can see what other jobs I need to be, or those other jobs will automatically be pulled up in the sequence based upon the setup codes I put in. But what's fun is when I'm doing this out on the shop floor and I get used to these priorities, and now I'm running the planning tool, the planning tool is also let in on that joke. So the planning tool will sequence the operations out in the future using those setup codes as well.
Okay, the next question is, how do you determine buffer time?
Great question. And we help you with that during the implementation, and certainly happy to talk about it prior to you making any commitment. And the short answer is your initial buffer times can be whatever lead time you're using today. Okay. The thing about protected flow, though, of course, is you want your framework size, and that's kind of the same as the lead time in protected flow, because it's that buffer plus the work that needs to be done. You want to make that as small as possible, while still being comfortable that you have enough buffer to get the jobs done. So it is a balance. Again, where we walk into shops where they have too much WIP, then the lead times are often, and the reason they have too much WIP oftentimes is that the lead times have been exaggerated. And unfortunately, what some shops do, it was a point on one of the slides, but I just blew through it for time's sake. What many shops will do is they'll say, "Gee, I'm late. I'm quoting 6 weeks, but I'm always late on that job. So instead, instead of releasing it 6 weeks in advance, let's release it 8 weeks in advance." And instead of helping the situation, per Little's law, they're actually making it worse because now they're releasing even more stuff out into WIP and slowing things down, clogging up the resources, and confusing what the true priorities should be. So long answer to a very good question. The buffer sizes, we work with you to decide what they should be. They can be a factor of the work that needs to be done. They can be a fixed amount of time. They can be a combination of those two. Again, we will work with. They can be set at the site level. Buffer sizing can be set at the part family level, at the part level, or right down to the work order level. So you can override what your buffer size is at any of those levels. The neat part about the planning tool is, as it's a simulation, you can set up certain buffer sizing parameters, run the planning tool, and it will simulate how your jobs will be executed using those buffer sizes. So you can go in and look, what are my predicted finish times, and where do those fall in my framework? So one of the features of the system is you can determine a minimum comfortable amount of buffer remaining, and any job, the system will then flag any job that will have, per the simulation, that will have less than a comfortable amount of buffer remaining at its finish point, and flag that as an exception. So you can go in and see why. What other jobs did it run into? Was it material issues? Was it people issues, et cetera?
I'm afraid we've run out of time, but I want to thank Mark Lilly for an excellent presentation today, and I'd like to thank our sponsor, Protected Flow Manufacturing. As a reminder, if you're registered as a group, please add the names and emails of all in attendance on the exit survey. And on behalf of Industry Week, have a productive remainder of the day.
Thank you very much.